Question 18 says, a point object O is placed in a medium of refractive index mu1 equal to 4 by 3. S1 and S2 are two concentric spherical surfaces of radii 1 meter and 2 meter respectively. The material space filled in the region between S1 and S2 is of refractive index mu2 equal to 3 by 2. Find the object distance of O from S1 in meter so that an image of O as seen by an observer in air medium right of S2 coincides with object O itself. Well, the question requires repeated application of refraction at a spherical surface. For the first refraction, our equation will be 3 by 2, which is mu2, by V1 minus 4 by 3 into minus x is equal to 3 by 2 minus 4 by 3 mu2 minus mu1 by minus 1. This surface has radius 1 meter and this surface S2 has radius 2 meter. So this is the equation. Let's simplify further. The right hand side becomes this will be minus 6 here, and then this is 9 minus 8 or minus 1 by 6. Left hand side is 3 by 2 V1 plus 4 by 3x. Right? Now, if I further solve it, I get 3 by 2 V1 equals minus 4 by 3x minus 1 by 6. Let's say it is 6x, then this is minus 8, then minus x, which means V1 can be written as 9x or minus 9x by 8 plus x. Right? So let's say somewhere here is the image formed by first refraction. This distance is 9x by 8 plus x. Well, it's very clear that for the second refraction we should have V2 equal to what? The image should form at here, at this point only. That means V2 is equal to 1 plus x, okay? Or rather it is minus of 1 plus x. V2 is minus of 1 plus x for the second refraction, and let's write the equation now. Equation is 1 upon minus of 1 plus x minus 3 by 2 into u. U is, as I said, it's equal to minus sign will come, so that means this will come plus here. It is 9x upon 8 plus x plus 1, and this is equal to 1 minus 3 by 2 divided by minus 2. Well, if we simplify this equation and solve for x, we get a quadratic equation whose solution turns out to be x equal to 1 and x equal to minus 2. We obviously discard x equal to minus 2 and we consider x equal to 1 as the solution. Then our answer is 1 meter. Right? So our answer for question 18 is 1. Let's now go to the next question. Question 19 says, a time varying magnetic field B equal to 1 upon 3t Tesla exists in large cylindrical region with center at origin. Find the magnitude of line integral of induced electric field, integral E dot dl, along a path given by equation 3y minus 4x minus 24 is equal to 0 in between the path where the said line crosses the coordinate axis. There is a straight line. We can write it as y is equal to 4x by 3 plus 8. This is the equation of a straight line, which means that this intercept is of 8 units. This angle is 53 degree because the slope is 4 by 3, which means this side is 6 and this length will be 10 units. Now the magnetic field is changing, so there is induced electric field here being produced, and we have to find the integral of E dot dl from between these 2 points. If we go from one point to the other along this line, what's the value of integral E dot dl, right? Now we can make this problem pretty simple by using Faraday's law also. For example, if we look at this triangle whose sides are of dimensions 6 units, 8 units and 10 units, we'll consider them to be in SI units. That means we are considering that this side has 6 meter length, this side has 8 meter length, and the hypotenuse has 10 meter length. So the EMF produced in this triangular area by Faraday's law is equal to EMF, as I said, is equal to area of the triangle, which is 1 by 2 into 6 into 8 into dB by dt, which is 1 upon 3 units. So this is simply 8 volt in SI unit, right? This is the EMF being produced. Now if this is also equal to integral E dot dl along this path, now of the 3 segments, E dot dl, value of E dot dl for this radial path and this radial path is going to be 0, because electric field will be perpendicular to the radius at any point. So that means integral E dot dl for the hypotenuse is going to be 8 volt only, which means our answer is simply 8. Pretty simple, isn't it? Let's go to question 20 now. Question 20 says, for the circuit shown in figure, at the given instant, voltage across capacitor is 25√3 volt and voltage across resistor R1 comes out to be 25√n volts. Find the value of n. Again we have an AC circuit with 2 parallel branches. Well, the impedance of this segment is under root of R square plus root 3 R square, that means 2R. Impedance of the upper segment is also 2R, that means the RMS value of current will be same in both of them. But here we are talking about instantaneous value of voltage. Okay, let's say this branch has current IC, so we can write instantaneous value of IC as 50 upon the impedance is 2R sine omega t. Now the current will lead the applied voltage and will lead by how much? Tan inverse root 3, that means 60 degree. So that means this current is 50 by 2R sine omega t plus 60 degree. And potential difference across the capacitor VC will be, its peak value is going to be IC multiplied by XE, that means it is 25 by R into root 3R. Now this VC will lag behind this current by pi by 2, that means its phase is given as sine omega t plus 60 degree minus 90 degree, or it is 25 root 3 sine omega t minus 30 degree. Right? Now if this value at an instant is 25 root 3 volt, so this is 25 root 3 volt, this means the value of sine omega t minus 30 degree can be taken as 1. Let's now derive similarly the expression for VR1, right? Because we are concerned with the voltage across R1. So first we write the current in that branch. Let's call it IL. The current will be same in the inductor and this resistance R1. And this is equal to again 50 by 2R, because the impedance of that branch is also 2R, sine omega t. Now the current here will lag the applied voltage by how much? It will lag the applied voltage by tan inverse 1 by root 3. That means 30 degree. So this is 30 degree. Now VR1, or simply let's call it V1, potential difference across R1, is now this multiplied by resistance, which is 50 by 2R into root 3R, and this voltage will be in phase with this current. So it is simply this into sine omega t minus 30 degree. Now we have already seen the value of sine omega t minus 30 degree is 1. So that means V1 equals 25 root 3 volt. This means the value of N equals 3. So our answer to question 20 is 3. Well students, that we come to the end of this quick solutions. Thanks for watching and wish you all the best for your preparations and the forthcoming examinations.